ENEOS SUSTINA, a revolutionary engine oil providing exceptional sludge protection and long-lasting fuel economy. The function of engine oil. When the engine is off, oil settles to the bottom and collects in the oil pan. When the engine starts, the pump draws oil up from the pan through the oil filter to the oil galley. A number of oil passes route the oil from the galley to the engine components. Oil supplied to the cylinder forms a lubricating film that allows the piston and rings to move freely. There is also added space between the piston and cylinder wall to allow free movement of the piston. The oil fills the space and provides a seal for the high-pressure combustion process to prevent pressure leakage. The engine block is cooled by coolant or antifreeze, while the internal moving parts are cooled by oil. The oil keeps the engine clean by capturing soot and dirt produced by the combustion process. Detergents in the oil grab and suspend the contaminants in the oil while helping to break them down into smaller particles, preventing sludge buildup. As the oil ages and contaminants increase, sludge may begin to build up in the piston ring grooves. If the ring loses its ability to move freely, it can no longer seal, resulting in pressure leakage. Sludge can also build up on the piston under crown and skirt, which makes it difficult for the oil to reach the piston, affecting the oil's ability to cool and carry away heat. Oil neutralizes acids that are produced during the combustion process, providing corrosion protection to metal parts. Protecting the engine from corrosion caused by sludge, keeping the engine clean, is the most important function of engine oil. Sustina provides the engine with exceptional sludge protection, ensuring a long-lasting fuel-saving effect. Let's look at how engine oils are made. Engine oils are a blend of base oil and additives. So the quality of the base oil and additives directly affect the engine oil's performance. Sustina is made with W-Base, a revolutionary high-performance synthetic base oil and additives developed with ENEOS proprietary Zinc P technology. Now let us introduce you to the revolutionary W-Base and Zinc P technologies. W-Base provides up to 2% improvement in fuel savings. In this fuel consumption test, Sustina and other existing fuel-saving engine oils of the same weight were tested in a subcompact car and a mid-size passenger car. Fuel consumption was measured using temperature and humidity-controlled dynamometer test stands. The results showed that compared to the other fuel-saving oils, Sustina provided up to 2% improvement in fuel savings. In higher temperatures, the oil's viscosity decreases or gets thinner. In lower temperatures, the oil's viscosity increases or gets thicker. The degree of viscosity change due to temperature change is called the oil's viscosity index. The higher the viscosity index, the smaller the viscosity change with temperature changes. Let's look at W-Base viscosity at -5 degrees Celsius and 80 degrees Celsius. As you can see, the change in viscosity for W-Base between -5 degrees Celsius and 80 degrees Celsius is minimal. This means W-Base has a high viscosity index. Let's see how the oil's viscosity index affects fuel consumption. As the temperature rises, the oil's viscosity decreases, making the oil thinner. It is important for the oils to provide the viscosity required to protect the engine at the maximum internal temperature. However, since typical operating temperatures are lower than the maximum, the oil can have too much viscosity at typical operating temperatures, causing internal drag and reduced fuel economy. The key to reaching improved fuel efficiency is to reduce this extra viscosity that leads to drag. However, simply reducing the viscosity would compromise the oil's ability to protect the engine from damage at extreme high temperatures. To make the oil's viscosity stable from lowest to highest temperatures is the key to achieving optimal performance and fuel efficiency. The high viscosity index of W-Base enables Sustina to increase fuel economy without compromising protection. Although Sustina with W base may look the same as conventional oils, the molecular structure is quite different. Typical base oils have a complex molecular structure built from carbon formed in a ring-like structure. At low temperatures, the molecules cannot move past each other easily, resulting in increased viscosity and poor fluidity. The molecular structure of W base is different from that of typical base oils. Instead of the ring-like carbon form, the hydrocarbon molecules in W base are aligned in a straight line, enabling them to move more freely. The W-base hydrocarbon molecules move more easily at low temperatures, providing outstanding low-temperature fluidity. Let's compare the fluidity for conventional synthetic and W-base oils at 0 degrees Celsius. Now compare the same three at 25 degrees Celsius. At both temperatures, the balls fall more smoothly for W-base, providing low resistance to flow. W-base provides less resistance to flow for easier engine starting and running, making it possible for Sustina to offer up to 2% improvement in fuel savings. Sustina's additives are made with our new Zinc P technology, a revolutionary advanced additive chemistry from Nippon Oil Energy. Zinc P technology features optimal combinations of our groundbreaking proprietary additive Zinc P. We compared the cleanliness of head covers in a low-temperature stop-and-go driving simulation test using Sustina and another fuel-conserving oil. The left shows results with Sustina and the right shows results with other fuel-saving oil. Look at the results after 5,000 kilometers. Now at 10,000 kilometers. At 15,000 kilometers. And finally at 20,000 kilometers. At 20,000 kilometers, the head cover with Sustina was cleaner than the head cover with the conventional oil at 10,000 kilometers. This test shows Sustina keeps engines clean twice as long as conventional oil. This advanced cleaning performance was also seen for pistons used in a high-load driving simulation. You can see a clear difference in cleaning performance. For Sustina, metallic parts are quite visible. Deposits and sludge are minimal in the piston ring grooves, an area where proper lubrication and sealing are critical. These factors give Sustina the ability to keep engines clean twice as long as ordinary oils. The secret to Zinc P technology lies in the elimination of sulfur. Conventional additive chemistry like zinc DTP contains sulfur. Inside the hot engine, water, oxygen, and sulfur additives can form sulfur oxide and hydrogen sulfide. These compounds can ultimately form sulfuric acid. Let's see how acid affects the cleaning performance of engine oil. Engine oils contain detergents that encapsulate soot and dirt produced in the engine. These detergents suspend the dirt in oil, preventing it from settling on engine parts. As long as there are detergents in the oil can prevent the engine parts from sludge. How does sulfuric acid affect this process? Detergent additives are alkali in nature, which are neutralized and eliminated if attacked by acid. The sulfuric acid continues to neutralize the detergents, rapidly reducing their number. Once the oil detergency is gone, sludge is free to attach to critical engine parts. Detergent additives can perform at their full capacity when not exposed to acid, keeping engines clean for long periods of time. Zinc P additive chemistry does not contain sulfur and thus will not form sulfuric acid when exposed to heat, water, and oxygen. Zinc P technology suppresses the production of sulfuric acid, allowing the oil to perform longer. Groundbreaking Zinc P technology allows for optimal performance with zinc phosphorus chemistry. This technology has reduced the sulfur content in the oil by 70%. This is the secret for Sustina's advanced cleaning performance sustainability. Long-term cleanliness provided by Zinc P technology also contributes to improved fuel economy. Zinc P technology also contributes to long-term fuel efficiency. For example, if the typical fuel-efficient oil when new is rated at 100, Sustina when new would provide a 2% improvement in fuel efficiency. In simulated high-speed driving over 15,000 kilometers, Sustina showed minimal loss of fuel-saving performance. Sustina retains a higher fuel-saving performance even compared to the typical fuel-efficient oil. After 15,000 kilometers of simulated high-speed driving, the typical fuel-saving oil loses a significant amount of fuel-saving performance. By comparison, Sustina has exceptional fuel-saving performance sustainability. Sustina's outstanding low-temperature fluidity from W-base and its superior cleaning performance from Zinc P technology make it the perfect choice for use with today's engine, featuring new cutting-edge technologies. Today's engines are subject to many new processing methods to reduce energy loss due to friction. Cylinder walls undergo plateau honing processing, a polishing process that smooths metal surfaces while leaving a deep groove for oil pooling. Also, there are various new procedures including streak finishing and patterns coating applied to the piston skirt. Piston rings are made from lighter materials with higher tensile strength. Sustina keeps critical engine parts clean, allowing these technologies to work longer and more efficiently. Sustina works in all types of inline and V-shaped engine configurations, including turbo and supercharged, to keep engines clean and provide long-term fuel-conserving performance. Everyday stop-and-go driving and short-distance driving may not seem like severe driving conditions, but can actually accelerate the breakdown of engine oils. During the combustion process, hydrocarbons react with oxygen with the engine to form water. This water normally evaporates when the engine and oil temperatures are high. In lower engine temperatures, water does not evaporate as easily, making the oil prone to the effects of water buildup. This water can contribute to the production of sulfuric acid that attacks detergents and reduces cleaning ability. This condition is common with late-model hybrid vehicles and idle-stop vehicles. Sustina, using sulfur-free Zinc P technology, is resistant to the negative effects of moisture in oil, providing long-lasting cleaning performance. When considering high engine speeds, one often thinks of highway driving. But today's more popular compact and subcompact cars put more strain on the engine because smaller displacement engines must run at higher RPMs to be able to support the large mass of the car. Sustina oil made with high viscosity index W base can provide the proper viscosity needed at high temperatures, provide superior oil flow needed at cold temperatures and at high engine RPMs, and maintain fuel-conserving performance over time. Outstanding fuel-saving performance made possible by the high viscosity index of W base. Long-lasting cleanliness performance achieved through new Zinc P technology, reducing 70% sulfur content. Sustina is a new kind of engine oil designed to promote cleanliness and fuel savings in all types of engines and all types of driving conditions. ENEOS Sustina motor oil is the next generation motor oil available today, meeting the needs for tomorrow.